Welcome back to PEEPanEIP, an educational video series where we learn about an Ethereum improvement proposal, upcoming upgrades, and the basics of Ethereum blockchain. I'm Pooja Ranjan, and today we are going to talk about EIP-2098 compact signature representation. To talk about the proposal, we are joined by one of the co-authors of the proposal, Richard Moon. Richard goes by Rick Moo on some of the social media platforms. He is the lead developer of Ethers and Firefly, the $5 DIY Ethereum hardware wallet. Welcome to the show, Richard.
Cool, thanks. It's good to be on.
Yeah, I was super fascinated with the DIY hardware wallet. Just a little backstory here. Personally, my team was working on developing a HD wallet at the time. So when we saw your project, we were super fascinated with that. And kudos for your work, because that was like something very simple that people can do it at home.
Yeah, I mean, yeah. As I say, it's been very exciting seeing people actually like buy the parts online and build one for themselves. So that's
right. Yeah. Cool. Moving on to today's topic, let me provide a brief introduction to the proposal. EIP-2098 is a compact signature representation. This is an informational EIP documented in March 2019 and currently is in the last call with 13th February as the deadline. We will learn more about the proposal with Richard in a while, but before we get there, may I request Richard to share a bit of his background and his journey with the Ethereum and Ethers.
Sure. I'm not sure how much depth I should go into, but like basically 2013, I think is around there, maybe a bit earlier. I was at some hackathon and my friends were like, oh, there's this Bitcoin thing that just popped up in Toronto. Do you want to go see it? So we went out and looked at it. We went Bitcoin ATM. Of course, the building we wanted to see it in, it was all locked up because it was a weekend. And so we didn't see much more, but there's like a piece of paper in the window saying, oh, we have weekly meetups. And so I started going to those weekly meetups, which is where I met Vitalik and like a bunch of other like random like-minded crypto people. And it just kind of took off from there. Like it was just an exciting world to be part of. So that's what really got me into it. It's not like there's not a lot going on. It's just, it did not take much convincing. It just seemed awesome.
Absolutely. I mean, this space is pretty interesting and I'm a big admirer of your work. I hope the backstory also inspires many other developers. So moving ahead, we understand you have got a presentation to share.
Absolutely. So as a quick warning, this is a fairly short presentation, but this is what I've got to show off if anybody wants to pay attention to it. So should I just dive in then?
Sure, let's peep in.
Okay, peep in, I like it. So basically, compact signature representation. I'll go through my slides. I often over talk my slides, not realizing I've already mentioned something that's coming up later on, that sort of thing. So I'll just start going through and we'll see what happens. So first of all, what are signatures? So signatures is part of the proving system, which are used extensively through Ethereum. So like every transaction you send is signed by a private key, which gives you a signature. I'm also not exactly sure the target audience level. So if I'm speaking too low, please tell me to speed up through the list, or too fast, slow down, that sort of thing. Also, a lot of smart contracts use signatures because it allows you to prove that the private key of an account signed some piece of information, which is probably an agreement that the contract itself understands on how to perform that action or some action. So signatures, to give you an idea of what they actually include, it includes an R, an S, and a V. So the R is actually the X coordinate of some reference point. These are effectively created at random. So there's no interesting aspect to this really. The S is the important part. That you take an R and you do a bunch of maths to it. And this S is something that only the owner of a private key could actually have generated. So these two values together are kind of what allow you to prove that a piece of information was signed by a specific private key. Now, one of the cool things we do in Ethereum is we don't actually include the from address in a transaction. We have this ability to EC recover. We have the ability to actually, given an R and an S, figure out what the public key was that signed and created that S. One caveat of this is you don't need just the X value of the R, you need both the X and the Y value of the R. And so for any given X value, it's very complicated, but I'll try to skim over it. For any given X value, there's actually two possible Y values. So in order to get the entire R back from just the X, you need to know whether you took kind of like the top Y value or the bottom Y value. And so that's what the V is. The V is really just a 1-bit value that indicates to take either the first or the second of the two. I hope that's not over glossing things or over explaining things, but that's basically the idea of what this V is. And that's the V is really the crux of this entire EIP. So the next thing we need to kind of like dive into a little bit, again, just at a high level, is in Homestead, they released a requirement that all signatures are canonical. Again, we have like the situation where for any given signature, there's two possible signatures. We basically just forced it has to be one specific one of the two. So this was originally introduced in Bitcoin because they were having a big problem with transaction malleability, which is that someone could take your transaction, your thing you signed, and compute a second thing that was also signed by you but looked different. And this affects how their UTXO-based system works and that sort of thing. It was not nearly as important for Ethereum to solve this problem, but it's certainly a nice to have. Going forward, it just made a lot of possible things not a problem. The nice thing is this had a huge, profound impact on what we can do with this EIP, because we're taking the canonical signature, it locks one of the bits to always being 0. So I think that's mentioned in the next slide. Yes. So this is the consequence of having canonical signatures. If you see the hex value here, it's 0x1. That first character is a 1. So it turns out that because we're using canonical signatures, that first value can only be the values between 0 and 7, which means that if you take a look at the binary, that top bit is guaranteed to be a 0. There's no way that Ethereum will accept any signature for which that is not a 0. And so we put this all together. So you basically have this compact version of the S. And if the V, if you're trying to indicate the V should be 0 or 27, as a quick background on 27 versus 28, this was chosen again for like legacy Bitcoin purposes. Basically, things like 0 and 1 were already in use. Like there's very specific bytes they use to indicate this is a private key, this is an address, this is a compressed address, this is the upper part of a compressed address. So there's all these like existing values that were really important. So rather than using 0 and 1, they use 27 and 28. But the fact is we can just change that 27 or 28 into a 0 or 1. And so now we have this possibility where that one bit that we have left over at the top that would otherwise just be kind of like 0 all the time, we can kind of cram that extra bit of V into that little slot sitting there that's just otherwise going to be 0. So that's what this code is basically doing. And it's just a very pseudocodey thing, but it just shows you me pointing at the screen doesn't help. It's just showing that we pack that V into the top bit. If it's 0, we do nothing. If it's a 1, we change it to a 1. So as a quick size comparison, we could look at what Solidity would accept as call data if you're passing these into a Solidity contract. So if you pass in a signature today, like normal signatures as you're used to, so they're 65 bytes long. But if you call this in Solidity as a bytes object, that's 160 bytes of call data that you're passing along for the signature. If you use separate parameters, because of the way like alignment works in Solidity, which is everything is aligned to 32 bytes, well, that V is actually a 32 byte value. And so just passing in the signature is 96 bytes of call data. So if you use a compact representation, you can fit it in the R and the compact S. So you're at your minimal 64 bytes of data. So just some quick numbers, because numbers seem to be things people like. Over the bytes, it saves 60% of the amount of call data being passed in, and 33% for the separated parameters. And keep in mind that each byte you pass as call data actually has a cost to the transaction. Like you pay extra for each byte you pass into for your call data. So this is just gas saved. The 1 byte of call data would simply, the gas for that would cover the entire gas required for the extra small amounts of math you have to do internally to convert them. And so that's Solidity. And the other thing to keep in mind is now we have typed transactions, which means we actually have envelopes. All envelopes currently encode in R, S, and V. This actually means that every transaction type has an extra byte being stored that every node must remember for the rest of eternity. Like we're not talking about archive nodes, we're just talking about regular full nodes have to remember this value for the rest of eternity. So if we, for example, if we have a type 3, whatever happens after EIP-1559, we could remove that, and now every transaction is just 1 byte smaller, which is not a huge savings because transactions are like 400 to 500 bytes each. But just as a quick example, I was just doing this last night, it popped in my head and I was thinking about it. Right now we're sitting at 14 transactions per second, so let's put 1.2 megs per day that we simply again throw to the wind, and we literally lose nothing. Like there's no cost to this. This is data that we're just storing 8 bits around in a database somewhere for the purposes of just remembering that 1 bit of data. One other quick note is fully backwards compatible. Existing signatures are 65 bytes long. These are 64 bytes long. So you can programmatically detect which one is being used and kind of flip over to one or the other. Somebody was pointing out on Twitter that OpenZeppelin already supports this EIP-2098 standard. And so they are back to using the bytes size, which would be not the 160 bytes. If you pass this in, it would be the 160 minus 32, so like 128, that makes sense. So even if you use this with legacy bytes systems, it's still knocking off an entire word or 32 bytes from call data. But it means that the contract can detect, oh, this is a compact representation, therefore, blorp, do this other thing. And I think I've spoken very fast and got through my slides, and so I will turn it over to questions and that sort of thing.
Cool. So maybe if I could just take a few quick questions on this. When we're looking at something like 2098 adoption, so I think one of the big questions for me on like app layer development is, are you looking also for like level to handle these the same way we've got support for canonical signatures right now, like to be able to say EC recover out of signatures or things like that?
I mean, and I would absolutely love to see that. I think that does make a lot of sense. And the thing is, you don't need to change the precompiles or anything. The precompiles, in my mind, probably shouldn't change. But Solidity, for example, could offer a EC recover keyword. You can imagine Solidity could offer a actual built-in function that takes in a signature or because it's a different type of parameters, you could even imagine the signature for the function is different, and therefore there's not even a need to specify compact or otherwise. The function itself could know if I got 2 parameters versus 3 parameters, that sort of thing.
Interesting.
Is that what you mean, or?
Yes, it is. I mean, because I've looked a little bit at 2098 in my work, and that was always kind of one of the things that I ran into. Like, I didn't like always wondering if anyone's going to be passing in a 2098 sig, because right now the tooling is so much more there for canonical signatures that like trying to see like where the ecosystem is going to go with this. Like, and also I guess what your intent is behind the EIP, just to see if we're going to try and get this to the same level of adoption, use, traction, or whatever might be best there in the space.
Right, and so as a quick aside, the original EIP, I did have like a block of code that kind of implemented it to show how the Solidity would look. The Solidity is like an extra 3 lines of code, and I think the gas requirements were like an extra between probably 16 to 20 gas. And I think you're saving 68 gas per byte of call data. So saving, you know, an entire word of call data, or in the worst case, like 196 bytes of call data, easily pays for the extra small amount of math you have to do to munge this into the RSV that the existing precompiles are used to.
Mm-hmm. Very interesting. The other thing that I'd say kind of intrigues me here is there has been, I think that a lot of this is kind of inspired by 712, but then also specifically by ERC 2612. There's been a wave of kind of signature enabled applications. So what 2612 does is it allows you to sign a message and pass that signed message to someone, and then they're able to basically get an approval over your ERC20s using the signed message. So the specification inside 2612 specifically breaks down into VR and S. I believe some MakerDAO code does too, but I wouldn't know exactly where off the top of my head. And I think that that's at least, it could be I'm getting the entire history wrong, but it's looked to me kind of like the history of splitting signatures into VR and S on chain to get the bytes 32 bytes 32 bytes 8, so that you know exactly which types are coming in. You're not stuck with an entire unbounded dynamic bytes array and all of that. If 2098 would start getting traction, so that would mean that it wouldn't work with 2612 out of the box. And a lot of DeFi, for instance, you wouldn't be able to access with the 2098s.
Absolutely. And so, oh, sorry, go ahead.
No, I was just going to say, like, what do you have to say about that kind of a thing?
Right. Okay. I see. Yeah. So basically, I do see, for example, like there's a lot of existing things that already use a VRS. You could imagine there could be an amendment where there's like a permit that takes in a R and a compact S or some equivalent of that sort of thing. It's true, there's lots of things that exist that use the VRS already. I would also expect a lot of libraries to kind of be wrapping these things already, and they can kind of handle a lot of this internally for you. In terms of, I had a second thought, but I'm slowly losing it. It's on the tip of my brain. Right, so instead of using bytes, right, it's structs. So the cool thing about how Solidity also works is if you could, for example, have a struct called a signature, which could have 2 byte 32s. And that also greatly simplifies what the signatures would look like. And I almost kind of want to see that kind of be the path forward, rather than seeing this bytes 32 R bytes 32s U8 int V. I'd rather see a tuple bytes 32 and then sig. That just means it requires no additional bytes. The Solidity compiler will generate probably the exact same code. And for example, if you are using Ethers, by the way, I probably should have mentioned earlier, I'm the author of Ethers.js. If you use Ethers, there's already 2098 support in when you generate a signature, it generates an underscore VS. That was the underscore because it's experimental. The VS was the original name. I need to update it for the EIP. In version 6, it'll just be like a native thing that you can pass into any EIP-2098 enabled signature, and it will automatically just kind of compress it down to the right size for you and pass that in. It is definitely an issue that there exists a ton of things out there that are already expecting a VRS. I mean, I have a ton of things out there that use VRS, and this is kind of one of the motivating reasons, because there are so many things. And I'm not saying this is a change that either needs to be made overnight, or it's not even changes to be made exclusively. You could imagine having a second permit, which takes in a compact representation and simply just calls the other version after extracting the various components it needed. And you can, and again, in the future, I would like to see like new standards start to adopt this style. And I also want to point out, like, the still internally canonical signature. Yes, it's just we're kind of hijacking that one bit, but we're still requiring that the signed data be. I guess gone into more details about canonical signatures. Canonical signatures just means that the S value is between the values of 0 and the order of the SecP256K1 curve divided by 2. Yes. So I mean, it's just kind of like this is more about encoding than it is about changing the signature type or the signature represent. Like the signature format is still the same. It's just the encoding is different. So yes, I'll leave it at that.
Mm-hmm. Actually, maybe if I could what you were saying about the Ethers tooling. So it's, if I'm understanding right, you mean that when you use Ethers to generate a signature, so it'll generate in 2098 format automatically, and then let's say I would be passing that into some I do know that you can deconstruct that into VR and S. Are you saying that what happens there under the hood is that essentially it generates it in 2098, but if I specifically ask for the S, it decompresses it to?
No, sorry.
Or the
So
V,
I guess
sorry.
right. So what I'm saying is basically when you split a signature in ethers, it gives you back an object. That object has a V, an R, and an S, but it also has like a recovery param. So it's converted that V from 27 and 28 down into a 0 and 1. So it's more adjustable. And it also produces a underscore VS, which is the compressed, the compact S. So, and in Ether's V6, it'll do the same thing, but it'll do it on the fly. So by default, or the way that V6 works is VR and S are internally stored, but it's just an object with getters. So if you ask for the compact S, for example, it at that time will compute it for you and give it back to you. And so you can imagine, yeah. So if you had, for example, a function call that took a struct that required a R and a compact S, and you passed in one of these objects, it would just know to use those two portions of the
signature.
Thank you. Yes, exactly, signature. And for example, it works the other way too. If you had a structure that had a bytes 32R, a bytes 32S, and a uint A to V, if you pass that same signature object into a contract, it will automatically it'll pull that out for you, and it'll just use the 96 bytes instead of the 64.
Yeah, that actually really does sound very cool in terms of tooling. There's mixed feelings out there, I think, about the overloading and Solidity. It comes up a lot of times around the NFT contracts. But
I absolutely agree with overloading is not I mean, I'm not on the side of overloading as a good thing, but it exists. And so it's something that I think, yeah. Anyways, I
was actually about to say something very similar to you, I think, which is that sometimes in a situation like this, where like we already have kind of one paradigm that's there, and instead of creating kind of like standards for, there is a way to accommodate everybody. Like it definitely seems like a very, very reasonable approach.
Right,
yeah.
Right.
Very cool. You already mentioned the Open Zeppelin signature checker. I wanted to mention that so it does also pull in the 2098 support off the bat. So there is like easy ways to already check those signatures and work with them on chain. But I do think that
a lot of things might even work with them and not even know it. Like think of all the contracts that are just using Open Zeppelin and already support this, and the authors themselves don't even know that compact signature representation works, that they could be using in their UIs.
And their function signature probably has VRS, yeah. 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 I think that's it for technical questions from me, though. So, Pooja, if you wanted to take your questions.
Well, thank you so much. I mean, this was a great talk, a small presentation, but quite informative. As you mentioned, that numbers are important, and you shared a lot of numbers. So we are good with that. Now coming up to some non-numerical part, like some basic questions around the proposal. My first question is related to the implementation. The proposal suggests that Ether's JS library supports this in version 5. So in simple terms, if we have to talk about like what this actually provide to a wallet or a DeFi project developer when they are trying to use Ether's library, especially when RLP encoded transaction, would there be an elegant script, or would it be building an economical DApp? What would be the major advantage of using this proposal?
I mean, the biggest advantage right now, I mean, when I came up with this idea, it was not nearly as important, but I think we all kind of understand the value of saving a little bit of gas now. And so if you can save like an extra couple hundred gas on a lot of these things, that's kind of, I think, the biggest advantage in terms of what I think a lot of DeFi developers would really care about, or DeFi developer managers at least. They see like it's slightly cheaper to run these type of signatures rather than traditional VRSs. Or bytes. I think the other big advantage though is actually just developer overhead. Like you pass in this one object instead of all your signatures have these like 3 components, and it just makes the code look kind of crazy because you have all these extra parameters you're passing along. I mean, there's that C paradigm or whatever, that if your function has nine parameters, you're probably missing a few. Like you don't want a bajillion parameters going into a function. It just becomes very complicated. So I think from a developer point of view, it's much simpler. But as William was pointing out, there's definitely going to be a legacy issue if you are a new age DeFi person and you're using some older contract. There is going to be a little bit of a hurdle for you in the sense that not really a hurdle, but you can't use this because you have to speak the way the old stuff used to work. So kind of a mixed blessing. I also feel like if this got traction and took off, it would be really interesting to come back in 2 years' time when all new standards are using compact representation, and for a new DeFi developer to come in and take a look at trying to interact with an older contract and be, what the hell am I doing here? Why am I passing in all these like crazy things? I just want to pass in a signature. I don't want to pass in like sig.v, sig.r, sig.s to see what happens. So if that's in the direction that your question was going, feel free to like ask refining questions.
Absolutely. Yeah, I mean, I'm also excited to see this proposal being adopted. And based on adoption, my next question is about the implementation. We did talk about OpenZappelin, and we are aware that Ethers.js have implemented this proposal. Are you by any chance aware of any other project those are either in active implementation or proposing to be? You can also suggest dApps that can be like benefiting from them.
Right. So I mean, in terms of implementation, in the original EIP, there was included a implementation of Solidity. Again, it's like, I think 3 to 4 lines of code. So you can see how the Solidity differs. But there was some, I guess that doesn't belong in an EIP. So I should probably create, an example somewhere else that demonstrates how to use it. I think I've actually used it in some of my hackathon projects, just because, again, it was simpler to like knock out. I'd have to look, but if I is out there, you can take a look at like Takoyaki, or actually, now that I think about it, I think even Firefly might have internally used this just to squish things down to a QR code. But at the time, it wasn't really an idea. It was just kind of me cheating hardware to make things work. But in terms of real world things that they're using it, I don't believe there's anything that's, at least nothing huge that I know about. I didn't really pay attention to that though. I haven't researched it at all.
No worries. We hope that when this proposal gets finalized, people give the proper attention this proposal requires, and it will be helpful for other new dApp developers to kind of integrate this in their upcoming projects. So it's good. Like I remember when Firefly was around, you had some concerns with QR code. So if that was implemented, like basic idea also there, quite interesting to follow.
I was going to say, like, basically the way the Firefly worked, for those who don't know, is it was a completely air-gapped hardware wallet. And so it had a radio that could listen, but it had no way to broadcast data back. This was a huge cost savings device back then. It didn't actually support Bluetooth, but it could kind of fake understanding Bluetooth packets. But the way it got information back into your computer was by displaying a QR code on the on its display that you could then scan, and then your scanning software would recombine that QR code into something more meaningful, the actual signature. And the problem was the screen's capacity to show a QR code could only show 2 side-by-side QR codes capable of storing 32 bytes each. And so there wasn't room to store the extra 8 bits of a V. I can't remember, we might have done one of 2 things. We might have crammed the V in there, or we might have just had the software compute both V0 and V1 and see which one matches the address. Those are both different solutions, and the latter solution is actually how a lot of software in the Bitcoin space recommended you do some of these sorts of things, which for your own personal use is fine. But one of the biggest hits, especially early in the blockchain, was signature verification was the thing that really chugged the really brought the speed of syncing the blockchain down. Because, and nowadays it's probably not a big deal. I mean, we can SEC-P256K1 EC recover like out of the wazoo. We don't care. So anyways, that's just some like random little tidbits of background information. So it might have been used. I can't remember whether we used that or just the kind of like just try everything and see what happens.
We hope that it is implemented in upcoming projects. Talking about the implementation only, would this proposal be somehow integrated with ENS? or if you are aware of any plan of ENS integration, maybe?
I mean, not really, there's not really much that ENS can do with it any more than anything else. I mean, it's just kind of like a different representation, like anything that you could imagine. Even a lot of like L2 solutions could start using this when they're providing signatures for one thing or the other. And so if there's any L2 stuff upcoming in ENS, it could probably use this, but I haven't really thought much about anything ENS specific that could use this.
I think there are something going on, like I remember reading somewhere ENS with L2, so
Right.
might be.
Exactly. I feel like this is the format that we should probably be using. I understand there's a lot of legacy things, and so that's kind of, it's up to kind of the community to decide, is like following legacy more important, or is kind of like using a newer but not widely adopted standard. Is it worth the time to make an unwidely adopted standard a widely adopted standard? So
that's right. Yeah, it's important that people understand the basic difference from what was existing earlier and what new proposals are coming up. And I hope the recording of this might help make the difference and pick up the right one, which is best suited for their project. My next question is about the type, or the type. I mean, when I was reading the proposal, it felt to me it can be something else, because we do not have a lot of informational proposal. This is as an informational proposal, so it was like more of a curiosity thing. But my question to you would be, why did you choose it to be an informational and not an ERC?
So we were actually, last night I sent Nick Johnson the slide deck to take a look at. And he mentioned that this shouldn't be informational, it should be an ERC. And I completely agree. And I mean, I would like to make that change to the EIP as well, to move it into I forget what the super type of ERC was, but there was standards track. So make it a standard track with the type of ERC. Absolutely. And you are completely correct. It should be. I just guessed that when I started this EIP, I don't even know, I'm guessing it was years ago. I'm guessing it feels like it's been through a few iterations of moving to stagnant and moving back out of stagnant. So
I've got it open in front of me, apparently March 14th, 2019. So you're coming up on its third birthday.
So there, oh, perfect. So there you go. You have an idea of like, that's how long ago it was. I mean, I probably read EIP 1 over and standards track and like that big block, because in my mind at the time, I'm guessing, I can't really fully appreciate where my mindset was in 2019. But my guess is I saw ERC and probably thought, oh, this is like ERC 20, ERC 721. These are probably like, in my mind, ERC was for tokens. And so I saw the word informational. I'm like, well, this is just an idea. It's not like so I mean, that is the best like argument or justification I can give for why I would have chosen such a thing. But having been explained that I should probably look into this thing and rereading the description of ERC, absolutely, it belongs in the ERC bucket of the universe.
I think that's going to be helpful for event developers, because in my experience, informational EIPs are generally neglected. They are not seen because they are kind of recommendation people may or may not use. But if something comes up as an ERC category, or maybe if that is of the more of protocol side in the core category, then people pay much attention towards those proposals. So yeah, that can be an added advantage to this proposal. I'm happy that you're planning to move it to ERC category.
Absolutely. It's just something I wasn't really even, this is the unknown unknown. I didn't even know that was a thing I didn't know. And I guess I didn't even know this thing you're discussing, like how informational are obviously overlooked. In my mind, it was just like, this is just an idea. It's not like I guess, yeah. Anyways, that's my, so I completely agree with you. You were 100% correct. It should absolutely be ERC, and I'll be making that change.
All right, that's good to know. I mean, I understand we were discussing this in our conversation today with one of the EIP editors, that sometimes it's not clear to author. What they can do is go ahead with whatever they find best at the time. But when we reach that proposal on like further statuses, we might want to look into deeper and help author decide the category. So glad to know we are on the same page on that.
Yes.
All right, moving ahead, my next question to you is, are there other EIPs? I know you have co-authored a lot of EIPs. So are there other EIPs that you would be really talking to, or maybe you are looking forward to see them in the final status?
I mean, absolutely. There's a bunch that I'm very interested in seeing, even just kind of move forward a little bit more in the process. I want a lot more feedback. I mean, my two babies that I just love is like described data and described transactions. I'm not going to go a lot into detail in them right here, but the basic idea is rather than signing opaque hashes, I kind of want the ability to sign a string. I want to be able to see a string that says you are about to send 8 wrapped ETH to the some address. And then when I sign it, it signs the data associated with that. Again, this is like another EIP or PEEPanEIP. I'll bug you about it at some point. I have one of the EIPs. It's actually going to be 4 EIPs in total, but of those, I need the first 2 to be accepted before I can open the second 2. And one of them is kind of like hung up right now, kind of out in space, waiting for to be even moved into like the EIP repo. But I've got an article that I've been working on that kind of helps explain the idea, because there's been a lot of confusion about how it works, because everyone's kind of thinking of how things have already been done. And they're not really seeing the extra step, how this is like a little bit different than the 600 attempts that have already been made to do the same thing. So those are like the 2 that are dear to my heart, but there's obviously like, I'm adding 2544 to ethers right now. For those unfamiliar with not memorizing every number in the EIP space, this is wildcard support for ENS. Basically means that you can now have like, the example I have, it's running on Ropsten right now, is you can basically have star.hatch.eth. And if you send ether to ricmu.hatch.eth on Ropsten, it will go into this account that is now only, which becomes a counterfactually instantiated proxy. So there's no contract code sitting there now. But if I, the owner of ricmu.eth, ever decided that I wanted to get that ether, only the owner of ricmu.eth can deploy that contract, get access to it. Anyways, it's super exciting, and it's going to be like, it's something I've wanted for a long time. We're going to see a lot of just crazy, cool, awesome ideas, I think, come out of what we can do with ENS once we have like proper wildcard support. So that's what I'm excited in. I mean, CCIP is also fairly exciting, which allows you to, I actually don't know the EIP number for that. It's like got a 6 in it, I think.
Yeah,
but,
yeah, that 3668, I guess.
Okay, yes, there you go. I knew 6 sounded familiar. So, and that basically allows you to like get off-chain data, call on-chain to get off-chain data, and then verify the data is valid and that sort of thing. It's way too complicated to even really get into right now. Even though it's very simple, it's the power of it is very hard to encapsulate into a concise bubble on this right now. But basically, it allows a lot of really cool things we can do with L2s, and even a lot of things like the what's it called, like the ENS airdrop or the Gitcoin airdrop. If they would have had access to CCIP in the day, then you could have done a lot more things on chain. You could have asked for your balance of your ENS tokens without having ever claimed them. Like, you wouldn't even need a portal or anything. It would just be something you could ask and it would give it to you.
I asked this question from Nick Johnson when we had him to talk about the CCIP, like why you did not do it when there was ENS airdrop going on. He said that we are a little late, but I hope that it's going to be useful for other projects who may plan airdrops in future. And also about the other proposal that you mentioned about the ENS, I think 2544. Fortunately, we have a talk with Nick Johnson on that proposal as well. So I'm going to link here, so people who are interested to learn more about these proposals may follow the link and learn about it. And hearing after your interest, it looks like I need to book your calendar in advance to have you back to talk about more proposals, because I believe sooner we start talking about proposal is good for people to know, implement, and then help those proposals move towards the final status. I know we are a little late for this proposal, but we can make it up with the rest of them.
I mean, it's only been 3 years, but yes, exactly. Well, it was such a shame, because you imagine if I would have really, I mean, and that's one of the things, I guess it's a lot of effort, like Champion and EIP as it stands right now. If I would have really put the time in earlier on, like it might have been a year, 2 years ago we got it, and maybe we would have seen the EIP referenced, or sorry, William referenced the permit. Maybe it would have used compact representation. So yes, it's definitely good to get this in front of the eyes of people and get feedback sooner than later.
That's
Yes,
right.
that's
And
on me.
no, that's right. And talking in the same direction, I think I would be really curious to hear your thoughts on the present process. I know this EIP took long. It was over 3 years, about 3 years, like March in 2019, right? So, but it was not active for about a couple of years. From last 11 months, I see some more discussion going on in discussion tooling. So what is your general thought about the present EIP process, or if you have got any suggestion or recommendation to improve the present process?
Right. And so, I mean, I think I was mentioning this to a few people earlier as well, is like, so I think the EIP process is incredibly important. And I do find right now it's a little bit slow. It's a little bit like, it's a little bit frustrating as well, because you basically you do all these changes and you get like it back, and it's justifiably so, but I feel like you get back a lot of nitpicks and that sort of thing just to move a little bit more forward. So it's definitely, you have to dedicate time to it. If you have an EIP you want to put forward right now, it's actually quite time consuming. And I do worry that there are maybe people out there with ideas that put them forward that we're not even seeing get as far as getting pushed to the point where there's even anything to talk about. I mean, I have no idea. This is just my idea. My thoughts are there might be, I know I've got one EIP that I've been kind of pushing for quite a while. I mean, not quite a while, let's say like maybe 6 months, but it hasn't even made it so far as to like really getting into the repo yet and that sort of thing. And so it definitely, there's times where I feel frustrated, and I don't usually feel frustrated. I'm usually a pretty chill guy. So I know that when there's something that makes me feel frustrated, that either the process is too hard or maybe justifiably hard, and I'm just like, you know, hitting the edge of my patience or whatever on that sort of thing. So I think it's very important. And one thing I've heard like little inklings around here and there that a lot of the EIP process is basically volunteer work. And I think it's something that in general should be very much funded. I mean, this is the future of Ethereum. This is where the ideas of the next things come from. So if that's the only problem, if it's a funding issue, then I would love to see something. I mean, in my mind, the EF would almost just hire like EIP editors as part-time whatevers. I mean, I don't know, contract employee, whatever the system indicates. And again, I am not a manager. I'm not a coordinator. And so coordination is not my forte. It's not like my powerhouse. And so there's probably a ton of things, again, I don't even know that I don't know in this type of space that's difficult to manage, and logistics are crazy. You have all this like groups of people, and so I'm not blaming you. I'm not blaming the EIP process. I'm not blaming the cat herders. I'm just saying like there's definitely times where I'm trying to get something simple done, and it just feels like it's not moving forward. Like there's some typo in a thing, and as a result, the whole build fails. And next thing you know, your thing's being moved into stagnant, and then it takes you like 2 months to move it from stagnant back into draft. And so, I mean, right there's, so as an aside, there's one thing I think would be a huge help to even me personally, would be allowing if it's been draft, it went from draft to stagnant, going from stagnant back to draft should be basically a free operation. That said, I mean, now when I see something, when it says stagnant, I jump in quickly and make a white space change just to prevent it from like moving into that state, because that was the most frustrating state to be in. So sad. Anyways, overall, I think the process is great. I think it's putting a lot of great ideas out there. I love the amount of automatedness where someone approves a thing and then EIPs.ethereum.org is just like, blorp, here's your new information. So I'd say it's a love-hate relationship right now, or a love-frustration relationship, but I think it's not terrible, and it's something that's important to exist. And I'm happy that at least is something that I can use today and work forward. I'm not trying to be harsh. I want to make sure, like, I really do appreciate everything that EIPs and the cat herders and all the people do, but that's my kind of like 2 cents of a rant.
That's important. Like, some critics are also required because that's needed for the changes that is needed to make the process better. And taking some of your points that you just brought up, I would like to let audience know and rest of the people know that there are quite a few changes. Those are being done. We, the cat herders, are planning a bi-weekly call in which we try to go through every pull request that has been made in the past 2 weeks, try to read them, respond to them in sense like if minor changes are required, this is what you need to do, and just fix it up. We try to, like these days, we have been looking a lot into proposals or pull requests. They should not be long pending. Obviously, as you mentioned, the bot, they have helped a lot. So we have ECH engineering team, and our team is working on automation of the GitHub for this particular repository. And we are trying to look into proposals which are very long pending, stagnant, people lost interest to look, like pursue that proposal. We're trying to reach them individually, the authors, to help them push the proposal. I'll be really happy to help anyone if there is something related to process that they are not able to figure it out. We have this EIP meeting, which is organized alternate Wednesday at 1500 UTC, where we invite all the EIP editors to look into what's going wrong at the moment. So if there is any concern, they can just leave a comment. It's like all core dev meeting, but here it's not all core dev. Here it's all EIP editors meeting. So we try to talk about what's the showstopper here, what's blocking the progress, and we just try to help out the people. Other than that, we have started this EIP editors internship program to onboard more editors. That way, we hope that it's going to help more proposal get passed through the process fast. As you rightly mentioned, it is slow and it needs some support. So we are in the process of that. Hopefully in 6 months or 1 year down the line, process would be way more smoother. We have more people to review and look into it. So yeah, thank you so very much for all your feedback that you have shared with us. We'll try to go back to the recording, pick up one by one and
I do really appreciate the process. I am happy that it exists. Like, I also know there's so many things you have to deal with. Like one thing that just popped in my mind now was these spam, like bots trying to pretend they're actual real people by making weird pull requests. Like I understand there's a lot of things you have to deal with as well. And I guess exactly what you said, I think one of the I would say probably the biggest issue with EIP, with the process, is you're understaffed. I mean, I feel like everyone is, but it sucks that you're understaffed. And I guess this is where I'm thinking like maybe funding can help with the staffing issue. And like the internship program sounds great. So yes.
Yeah, we are hoping for like having some people get trained as an EIP editor, because this is, as you mentioned earlier, it's something very important for Ethereum. So we would like to have people who have been here in the Ethereum space for a while. We cannot just have new person getting in because it's not working. Person has to understand everything, like how it will be fitted in the system. So it may take time, but I hope that we are moving in the right direction. And thank you so much. I think that's all from my end on the question side. And it's almost close to the end of the meeting. So anything else that you would like to share with our viewers or upcoming developers related to this proposal or in general?
I mean, I don't think there's much I've got. I mean, it's been a lot of fun. Thank you so much for having me. And I apologize if I vented too much, but I mean, it's been a great, it was a great process. Like I really enjoyed like having a chance to talk about it, and I'm looking forward to kind of seeing what others think about EIP-2098. So.
Awesome. We appreciate you taking out time to talk about this proposal EIP-2098. And I was hoping it to become the second final EIP of informational category, but now we think that sorry. That's great. I mean, I'm not sad about this part, because I'm hoping this proposal will be widely implemented. So it actually will be used as a standard. So that's a plus point. All right. On this note, thanks to all our YouTube viewers for watching this episode. Check out the description section for related links and guest Twitter profiles to follow. If you like the talk, hit like and share. Should you have any question, leave a comment or reach us on ECH Discord. Subscribe to ECH YouTube channel if you haven't done it already. See you in the next week with another interesting proposal. Till then, keep watching, keep sharing your love with Ethereum cat herders. Have a good day, everyone.